Any sufficiently advanced technology is indistinguishable from magic. Arthur C. Clarke said that. And wow, does it feel relevant today?
It really does.
Imagine this. A laser beam, right? Weak as maybe a tiny nightlight, but it's outperforming leading satellite internet from like 60 times farther away.
Yeah.
And transmitting data 5 times faster. It just sounds, well, impossible.
Almost, yeah.
But it's real. And that's what we're diving into today. China's huge new step in satellite communication.
Exactly. So our mission, if you will, is to really get into the mechanics, the core tech, and the pretty big implications of this achievement.
Right.
We're basing this on that recent piece in Daily Galaxy, the one titled China's Laser Leap, Outpacing Starlink with Faint Beams.
And look, this deep dive is, well, we think it's super relevant for you. Maybe you're a UPSC aspirant, tracking current affairs. This stuff is gold for prelims and mains.
Absolutely.
Or maybe you're just like us, curious about where global communication is heading.
Yeah, it's fascinating stuff for anyone.
So stick around. And hey, if you find this useful, maybe give us a like, subscribe, and definitely drop any questions or thoughts in the comments. We'd love to hear them.
Please do.
Okay, let's try and wrap our heads around this. Seriously.
Yeah.
A Chinese satellite.
Yeah.
It's way up there, 36,000 kilometers.
Geosynchronous orbit, yeah. That's 60 times higher than Starlink's typical 550 kilometers.
60 times.
Yeah.
And it used a laser that's only 2 watts. I mean, that's tiny.
Almost nothing in terms of power for that distance.
Right. And yet it beamed data down at 1 gigabit per second.
Which is, as you said, roughly 5 times faster than what you usually get from Starlink.
It just doesn't compute, does it? Sounds like that magic Clarke was talking about.
It really does. And that's what's so counterintuitive, but also so revolutionary here. We're talking about a laser described as being like a candle's glow.
Wow.
Piercing through Earth's atmosphere, which is notoriously turbulent. That turbulence messes with light beams, distorts them. It's been a huge headache for laser comms for, well, decades.
Yeah, I remember reading about that being the main hurdle. The atmosphere just scrambles the signal, especially over long distances.
Precisely.
And people have tried things, right, like adaptive optics, AO, or mood diversity reception, MDR, to sort of fix the signal or catch scattered bits.
They have, yes. AO tries to actively correct the distortions in real time, like smart glasses focusing the beam. MDR uses multiple receivers to try and catch different parts of the scattered signal.
But individually, they weren't enough for this kind of low-power, long-range stuff.
Apparently not. They helped, but didn't quite crack it for reliable communication under these conditions. The real breakthrough here, the game changer.
Yeah.
It wasn't just more power,
right.
It was smarter tech. This AO-MDR synergy concept, developed by Professor Wu Jian from Peking University and Lu Chao from the Chinese Academy of Sciences.
Synergy, so using them together somehow.
Exactly. Think of it like AO does its best to sharpen the main laser beam, correcting as much distortion as possible. But some light still gets scattered by the atmosphere, right? That's where MDR comes in more effectively. It acts like a really wide net, catching all those faint, scattered bits of the signal that AO might miss or can't fully correct.
Ah, so they work together. One sharpens, the other catches the stray pieces.
Precisely. They combine the cleaned-up main signal with the reconstructed scattered signals. It makes the whole system incredibly robust. It can piece together a clear message even with a very faint initial beam battling through all that atmospheric turbulence. They capture almost every photon.
Okay, that makes sense. It's clever. So what does this actually mean, for us beyond the cool science?
Well, the implications are pretty huge.
It feels like it could change a lot. Faster global data exchange, obviously.
Definitely. But also think about reliability. For industries like media, finance, telecommunications, even space exploration, having a stable, high-bandwidth link like this potentially anywhere, that's enormous.
Yeah, you could have, incredibly fast HD streaming, reliable video calls from really remote places.
And potentially without needing the complex, expensive ground station infrastructure that current high-throughput satellites often rely on. This could genuinely open up a new frontier. It might transform how we connect globally, maybe even help bridge the digital divide.
It feels like a fundamental barrier has been broken here.
I think so. Maintaining such signal quality over these distances with low power, it's a paradigm shift.
And, we have to acknowledge, this is a big moment for China's space program.
Undeniably, it puts them right at the forefront in this area of optical communication.
But it's also like a win for science globally, isn't it? It pushes everyone.
Absolutely. Competition drives innovation. This achievement will spur further research and development worldwide. We're seeing a real acceleration in space technology competition.
So looking ahead, what could this tech lead to? Faster internet everywhere.
Potentially, yes. Much faster, more accessible internet. But also, think about deep space missions. Communicating reliably over vast distances is critical.
Right, like Mars missions or beyond.
Exactly. And it could even improve things we use daily, like GPS, making it more accurate.
Wow.
This kind of laser communication technology is really poised to potentially surpass traditional radio frequency systems. Better bandwidth, higher speeds, and crucially lower latency.
Latency, that's the delay, right?
Yes, that tiny lag in communication. For things like remote surgery, real-time control of autonomous systems, or even high-frequency trading, minimizing latency is absolutely vital. This tech promises much lower latency than many current systems.
So it's not just faster downloads, it's more responsive connections too.
Exactly. It opens up possibilities for applications that just aren't feasible with current satellite tech.
Okay, this has been really insightful. It feels like we're on the edge of something big.
I think we are. Which brings us to maybe a final thought for you, our listener, to ponder.
Go on.
As communication leaps across these incredible distances, using signals fainter than we thought possible, what new frontiers for human exploration, for connection, really become truly limitless?
That's a good question to leave us with. Limitless possibilities. Thank you for joining us on this deep dive today.
Thank you.